in section 2, we are going to start talking about systems of equations, which should be review since you did talk about this in Algebra 2. So a system of equations is two or more equations that share variables. We are only going to focus on the system of two equations. We will not look at a system of three equations. So a couple things that kind of make up a system of equations: supply and demand, rate and distance, comparison. So there's a lot of different ways where you can set up two equations for a situation to solve. So just to review, there are three methods to solving a system of equations. We can solve by graphing, and then there are two algebraic methods: substitution and elimination. So I'm just going to review each of these methods through an example. So we have the system of equations x plus y equals 3 and y equals 2x minus 9. So when we're solving a system of equations, we're looking for the point where they intersect. So the value of x and y that makes the system true. So in order to solve by graphing, which is the first method we'll discuss, I have included a graph. Both equations need to be in y equals mx plus b form. So they need to be set up as linear equations. Our second equation is in that form. We have y equals 2x minus 9. Our first equation is not. So in order to get y by itself, we're going to subtract x from both sides, and we're going to get y equals negative x plus 3. So now both equations are in the correct format. Just to review, our x-axis is along the bottom and our y-axis goes up and down. When you are plotting a line, you start with the y-intercept. So if I have y equals negative x plus 3, I'm going to start at 3. And then my slope of negative 1 means I go down 1, right 1. I only go negative in one direction. I never go negative in both directions. And then I can go up 1, left 1 as well. Connect all of my points. And there is our first equation. So for our second equation, we have y equals 2x minus 9. So this time my y-intercept is negative 9, and my slope is a positive 2. So you go up 2, right 1. I could also go down 2, left 1, but I don't have enough room on this graph. So plot my points. So now I'm looking for where they intersect, which is right here. So now I need to figure out, well, what is that point? So if I look at my x-axis, my x value is going to be 4, and my y value is going to be negative 1. So we're going to write our solution as a point. The next method we're going to discuss is substitution. So if you are solving a system of equations by substitution, what you look for is for one of your equations to already be isolated. So either x equals or y equals. So if I go back to my original equation, x plus y equals 3 and y equals 2x minus 9, one of my equations is already set up this way. We know what y equals. Y equals 2x minus 9. So what I can do is I can substitute that in for my variable y in my other equation. So it becomes x plus 2x minus 9 equals 3. So now I have an equation that just contains x. Combine my like terms, I get 3x minus 9 equals 3. And now we're going to solve for x. So my first step is going to be add 9 to both sides. So we get 3x equals 12. Divide both sides by 3. And we get x equals 4. Which should match what we got by graphing, which it does. So far, so good. So now to solve for y, I'm going to plug in 4 for x into one of my two original equations. I typically go with the one where the variable you're looking to solve for is already isolated. So I'm going to use the fact that y equals 2 times 4 minus 9. So that becomes 8 minus 9, which means y equals -1, which also matches what we got when we graphed, which I can now write as the point 4 comma -1. And the last method we're going to do is elimination. So in order to solve a system of equations using elimination, they have to both be what's called in standard form, which means your x and y, so your variables have to be on the same side, and your constant needs to be on the other. So my first equation is already in that form, x plus y equals 3. My second equation is not, which means I need to go ahead and move my 2x to the other side. So I'm going to subtract 2x from both sides, and that is going to give me the equation -2x plus y equals -9. Now I want to decide which variable to eliminate. So in order to eliminate a variable, they have to have in both equations the same coefficient, which means the same number in front of that variable, but opposite signs. So I'm going to rewrite my other equation directly on top of it. So x plus y equals 3. When I'm deciding which variable to cancel, I look to see, does one of my variables already have the same coefficient? Because if it does, that's the easiest variable to eliminate. So if I look here, my y's already have the same coefficient. They're both 1 y's. However, they do not already have opposite signs, which means one of these needs to be a -y. It does not matter which equation you multiply by -1. I'm going to go ahead and multiply the bottom equation by -1, but I can just as easily multiply the first equation by -1. So my first equation hasn't changed, x plus y equals 3. I now multiply every term in the second equation by -1. I get positive 2x minus y equals positive 9. Now I'm going to add my two equations together. And when I do that, one of my variables should eliminate. In this case, it's y. So I'm left with 3x equals 12. We're going to divide by 3, and we get x equals 4, which again does match up with when we did substitution and when we did graphing. Now I'm going to go ahead and plug that into one of my original two equations to solve for y. And since I already plugged into the second equation for substitution, I'm going to go ahead and show you how you can plug it into the first equation. So we have 4 plus y equals 3. So then you subtract 4, and you get y equals -1. So again, I got the exact same answers as I did the previous two, which if I want to write as a point, is the point 4 comma -1. So no matter which method you use to solve a system of equations, whether it's graphing, substitution, or elimination, you always get the exact same answer no matter which method you use. Now some methods are easier to use than others. It depends on the situation. Obviously, if there are fractions involved, substitution is graphing is kind of the preferred method because you can easily graph fractional slopes, but if you have to do substitution or elimination with fractional slopes, it can get a little bit more difficult because you might encounter more fractions. So let me know if you have any questions about any of the three methods we discussed in solving a system of equations.